Hi, I'm Ben Wilson and I'm proud to be a geek.
I guess it started, when I was about 7, and that was back in the 80s. My dad bought a Commodore 64.
Back in 1977, they had this thing called a mini scamp, which was a little box that you built as a kit, and it had switches on the front and little LED lights, and all you could do was program it to chase LEDs across the screen.
I was always looked at as a geek when I was in school. Didn't really associate with the cool kids very much, but now it's certainly become chic to be geek.
I'm Luke and I'm a late blooming geek.
I'm William, I'm proud to be a geek.
I love being a geek because I love being around intelligent people that can resolve problems.
The most embarrassing thing probably for me is the very first word I could ever spell when I was 4 was Windows.
Everything about it, the involvement, building something, it's like architect within the mind.
They're the great moments you wait for. When the light comes on, you just go, that's it.
I went home, told my dad, I said, Dad, I want to study IT and computers. And he said, what do you want to study that for? It's never going to take off.
So would you say you're a proud geek?
Oh, absolutely. There's no fighting it. There's no fighting it.
Love with a passion. So why do I love working in IT? Because number one, I get to play with really cool toys, and number two, I get to play with cool stuff that really does make a sort of impact to people and to their businesses and to their organizations, and makes the world a better place.
Geek and a nerd, so I fit into both camps.
Yeah, people say to me, what's it like being a geek, and I still remind them that in the year 2000 we saved the world, mate. No one believes us because we did such a good job at saving the world.
Hi, I'm Norman Judah, and I'm also a geek. I've been a geek for a long time. I love the technology and what I do with it, but something that I've realized in my 30-odd years of being a geek is it's all good and well playing with the technology, but we can also change the lives in the world, of billions of people around the world and make them special and make them different. So being a geek is one thing. It is also an incredible responsibility. I'm going to spend the next 45 minutes or so trying to wrap up what you've heard during the last couple of days when you've been in those labs or in those sessions, and try and put it all together. And I want to put it together in the context of the cloud, in the context of applications, talk to the infrastructure guys, talk to the app guys, and then pull it all together with what I think that future is going to look like. Here's a place to start. We sat down actually last year and wrote a press release, but we wrote that press release for 2015. And the story that we told in this press release is about a bank. You've probably met Contoso Bank because you've met many other Microsoft-like companies. And Contoso Bank has had this application in place for a long time. It runs in the cloud, multiple languages, multiple instances, highly scalable, elastic, grows and shrinks, has interfaces across multiple systems, and is up and running and available in 2015. And if that's true, in August 2015, we're writing that application today. We're designing and architecting and writing that application today. So though we think that 2015 is far out, it's actually much closer than you think. And so if there's one message that I want you to leave with today, it's that the cloud is real and you need to be thinking about it today. Not necessarily working with it today, but thinking about it today in terms of every project that you have today, everything that you're working on today. Step back for a second and think about what would I do differently if I was designing this architecture for the cloud, or if I was building this application for the cloud. What would I do differently? And if you would do something different, why aren't you doing it today? And let's talk about that as we go through the rest of the evening. So let's go back and look at some of the discontinuities that have happened, in this case, over the last 50 or so years. And one of the things that you'll see, it's very predictable, we have discontinuities that happen every 10 or 15 years. In our industry, and what that means is that we know there'll be another discontinuity 10 or 15 years from now and another one after that. Because inherently, the IT industry is about change. It's about incredible change, more than any other industry that we've known of for many, many, many years. And so the question is, what triggers these changes and what is the impact of these changes? Let's just look at some of these, because I think that they're actually, when you dissect them, the answers are sort of interesting themselves. If you look at client server 20 years ago, 25 years ago, that was really about consumers bringing PCs not only onto the desktop, but bringing PCs into racks and designing new classes of distributed applications. The internet and the web, although it was about browsers, and yes, it was about HTML, the key thing that the internet was about was the proliferation of information and essentially getting rid of information brokers. What the internet did is it allowed you to do self-service. It allowed you to go and find the information and seek it without having to go through a librarian, without having to go through a broker of some kind. Essentially, you had direct access to the information that you needed when you needed it. You could look at your bank account, reserve a seat on an airplane, transact on the web in some way, and that really was the fundamental change of what happened in that era. Sure, there were shifts in protocols and introduction of new technologies, but the real architectural change was the availability of information and the immediacy and accessibility of the information. The cloud is then adding a layer on top of that that really is looking at scalability, elasticity, resiliency, simplicity, but at the heart of the cloud is automation. And what I mean by that is automation is taking some existing running systems and producing an infrastructure that is predictable and repeatable in its behaviors. Repeatable in terms of things like elasticity or resiliency. That is the discontinuity of the cloud. But one of the biggest impacts of the cloud is going to be in a class of applications that we're starting to write today and will write in the future. Because one of the things that we're learning is that the user experience is just as important as the underlying architecture. The ability of people, of users, of various generations, different ages, different cultural backgrounds, to pick up an application on any device, a desktop device or a handheld device, to pick up that application and discover the functionality and become accustomed or at ease with that application, that's probably one of the toughest problems that we're faced with today. A great discontinuity that we're going through right now is virtualization. These are numbers that we've got from Microsoft, but are indicative of the industry, where if you look at the run rate of hardware servers versus virtualized servers, you'll see that the virtualized run rate is actually beyond the hardware. But what's interesting is as we speak, there's about to be a crossover in terms of the installed base of virtual servers versus physical servers. And in the next couple of months, we will actually be living in a virtualized world. A major change, and probably most indicative of the changes that are occurring inside of the infrastructure, but still have the following implications around the application side and developing applications. But this change to a virtualized world is the first step. Essentially what we've done is gone from what I'll call traditional data centers to virtualized data centers. But then there are a series of steps that come after that, going to private clouds, public clouds, semi-private clouds, virtual clouds, hybrid clouds. That is the next step. Virtualization is really this first minor step towards automation and the larger cloud. So the other thing that we're seeing on the infrastructure side and on the app side is the half-life of technology is moving more quickly than it used to. Previously, from a Microsoft perspective, the rate of change of technology was really in a 2-year window or a 3-year window. But what the cloud is doing is actually changing the rate of change. It's changing that half-life of technology from 2 to 3 years to 6 months to 2 months, and in some cases to 1 week. In many of the large web service sites that you see, Bing being one, there are experiments that are running on a weekly basis there. But in terms of infrastructure and applications, one of the biggest changes to people deploying technology today is, frankly, the rate of change and the ability to deal with that change with your end users and your consumers. There are some other things that are impacting us as well around the consumerization of IT, people bringing any and all kinds of devices into the enterprise. The one that I love is this fantastic explosion of data. With all these magnificently interesting devices comes communication and comes data. But let's look at it at the ridiculous extent of what's happening. Many of you at home today, I'm sure, have high-definition television sets, given that you're all geeks, and you probably have a Blu-ray player that hooks up to the internet as well. The number of IP endpoints in the network is growing exponentially, because in your homes today, you probably have anywhere from 16 to 20 devices that communicate in some way. Each one of those devices has an IP address. Given that we've run out of IPv4 addresses, you've now got to go to IPv6 in order to accommodate that. But think of all of the communications that's happening out of those devices. Think about every light switch in your house suddenly communicating. Your light switch now has to have an IP address, has to have an identity, has to have policy, authorization, authentication. You need to know everything about your light switch because you're not sure that you want somebody remotely being able to talk to your light switch, unless, of course, it's you while you're traveling, in which case you do want to talk to your light switch. So this explosion of data, security, and privacy is pretty fantastic about what's happening. Here's one thing that scares me. Every one of those television sets is running some version of probably an open source operating system today. No firewall, no antivirus. Think about all the bots that could be running on your TV sets today. Hundreds of millions of TV sets as hosts for bots that could happen today. And so the explosion that we're seeing today in terms of sensor-based networks and connected networks is going to have significant impacts on the work that we need to do around security and access and control in huge ways. But we are seeing a changing role in IT, which is IT as an organization having to deal with these multitude of personas and devices coming in on the network and gaining access to corporate resources. How do you provide the right level of control and access from an anonymous device or an anonymous user to your corporate assets? In some cases, going to your personal mail system might be fine, but going to corporate mail or corporate data or corporate processes means that you have to have a degree of identity and security and authentication in order to do that. So IT on the infrastructure side is really facing this incredible dilemma today of how to deal with all of these individuals and devices being able to access the network. There's another fundamental change that we're seeing as well, which is around how one evaluates the value of a device. Previously, when you would go out and buy a laptop, the price of the laptop in many cases was dependent on the size of the screen, the resolution of the screen, the battery, the CPU, the memory. It was a measure of physical attributes of the device. And one of the things that we're discovering in the last couple of years is that the value of the device, whether it's a telephone or a television set, is measured in many cases by its ability to communicate and collaborate. That device becomes a vehicle for you to share with others and have others share with you. The ability to stream content to you and to stream content from you. And so the economics of the ecosystem have changed dramatically given this proliferation of software and devices beyond what we ever thought when we were looking at the desktop. The biggest transition that we're seeing is the transition of software into services and the amount of work that it takes to take a software product and to convert that into something that looks, feels, behaves, and performs like a service. If you look at it from a server perspective, if you look at it from a Microsoft server, and look at what it takes to take one of our software products, a server product, SharePoint or Exchange, and convert those into a running service. Let me give you sort of a magnitude, order of magnitude of people. The Exchange server, the latest version of Exchange 2010, when the development engineering work was being done from Exchange 2007 to 2010, there were about 800 engineers involved in the development of Exchange. To take Exchange and SharePoint and actually convert those from finished boxed retail products and convert that into a running service in Office 365, there's about 1,200 people taking the packaged product and converting that into a service. Just something simple like provisioning or displacement or provisioning, locating a mailbox in a network. Let me give an example. Let's say you've got a data center that you're running 100,000 mailboxes. And you add a small company that's, 10 mailboxes. You could drop them in anywhere. But if you want to add another 50,000 mailboxes, the placement and the location of those mailboxes in your large network is crucial to the behavior and performance of the running system because you don't want to destroy the attributes of the existing running system. And so provisioning is one thing, but placement is another, and the automation and algorithms of placement are incredibly complicated. So it's more than just taking the product and actually converting it into a mechanism to publish the service. A lot of it is around the underlying infrastructure and the automation services that come when you do that. So two themes I want to cover on today. One is what's happening in the cloud, talk a little bit about that. But I also want to talk about user-centric computing because I think that the two are so tightly coupled Having a great cloud is one thing. With a badly written application, just gives you a highly scalable, badly written application. And so I think that it's important to actually talk about both dimensions of usability as well as scalability. So let's start on the usability side. If you look at this simple graph of a single device, when you start to use the device, it has a certain measure of its complexity, and the more you use it, the more you understand about it, and so the complexity of the device drops. You actually understand much more about the device and how you should use it. Here are some single-purpose devices. These are all, in fact, the predecessors to Connect. The first one is a towel dispenser that you'll find in many washrooms. You walk up to the device, you wave your hand in front, and it dispenses a towel. You could do that with a Connect today. Might be overly complicated. The second one is actually in a supermarket where you actually have a trolley, like this one over here, full of stuff, and you walk out to the door of the supermarket, and the door magically opens. Think of that as purpose-built Connect devices. In fact, these pictures come from Bill Buxton, who's a Microsoft researcher who was instrumental in the development of both Surface and Connect. And these are his slides, because he actually talks about that these are the things that gave him the idea for Connect initially, was to look at a device that actually understood some kind of motion. In the case of the towel dispenser, you wave your hand. In the case of the door opener, you walk towards it. But these are special purpose, single purpose devices that actually understand your intent and therefore can take the one action that they know. Here, have a towel, or let me open the door for you. And how can you then extend that more broadly in using Connect into a different set of devices? The user interface, what we've also discovered, is not as obvious as you may think. These are some of the very first telephones. I hate to think how many people in this room actually ever saw a working rotary dial. But at the time that telephones with a rotary dial were brought out, AT&T at the time had this 4-foot device that they would wheel around the country demonstrating to people how you can work with a rotary dial. It was not obvious to people at that time that the key to using this device was to put your finger into the number and turn it around. When you look at that phone, there's nothing obvious that tells you how that dial is going to work. And so one of the things that we've learned over time in doing user experiences and user interfaces is things that are not as obvious as you think they might be. What we find, though, as well with multiple devices gets really complicated. In this case, I picked the remote control problem, which I'm sure many of you live with, is this pile of remote control devices sitting on your coffee table in front of your television set, your Blu-ray player, your computer, and multitude of other devices that you've got. And the complexity problem of the user experience across multiple devices. Now, each one of these devices, these remote controls, is similar. It actually is trying to remotely control some device. But the buttons and the dials and the switches that they have on them are all different from one another for some incredibly interesting reason. There is actually no way of having a consistent remote control. And so if you go back to the model, what actually happens is that the complexity of multiple devices goes up, and it goes up exponentially. The more devices you add in, you lead to this frustration of which remote should I use, and do I press volume, do I press on, do I press off? And if you have a device, a remote that controls multiple devices, and you're out of sync where you press all off and some go on and some go off, how do you correct all of that? And so what we find is that the more devices typically you add, the complexity suddenly escalates dramatically. But there's another part of human psychology that we've learned, is the adaptability of the brain to complex systems is kind of fantastic, in the ability to take a system of multiple inputs and multiple stimuli and being able to model that in your brain and bring it down to a very simple thing. Think about when you were learning to drive. Some of you probably learned to drive an automatic transmission, and some learned to drive on a standard or manual transmission. The complexity, if you remember the first time you were trying to drive, between the clutch, the brake, the accelerator, the gear, steering, and putting on your indicators, seemed to be an intractable problem when you were starting to learn to drive. Yet, after doing it for some time, suddenly you find that it's actually simplified itself. Your brain has adapted an incredibly complex system and really simplified it to the degree where it looks like a single system rather than a connected model of multiple systems. And so the dilemma as we design user experiences is, do you build a consistent user interface, or do you build a consistent user experience? One of the things that we're doing and working very hard on is the consistent user experience, because we think the experience across device types is part of what's going to be incredibly important in the ability for somebody to approach a device without knowing what it is, gain access to that device, and understand how to use it and start to get discoverability and incredible benefit out of that particular device. We also start to see, as you have multiple devices, the litmus test for the user experience is how well do the devices work amongst themselves, how much value is there within the device and between the devices. And frankly, if you don't get exponential growth in the value between devices, you probably need to go back to a small number of individual devices, because the synergy of the devices and how well they work with one another and how well they integrate with one another really becomes a key factor to the success of them. However, certain devices are built for certain things, and they're very specific in their usage scenarios. A telephone, Windows Phone in this case, has what I believe, what we believe, and many analysts believe to be an incredibly simple, interesting, easy to learn, easy to understand interface. Except when you're driving. Because when you're driving, you probably should not be using your phone. And so you discover that the user experience on most phones is not built when you're moving. It's actually built generally for when you're stationary in some point, not walking, not driving, not on a bicycle, but having the ability to use your phone. And so the specific characteristics of the usability are pretty important. Let's take a look at something like Kinect. I'm sure some of you last night were playing with Star Wars and these other games that we had out there. Lots of the physical movement, but one of the things you realized, you have to have some space when you're actually playing some of those games. Kind of difficult to play with a Kinect if you're in an aeroplane seat. And so the specificity of the device and its usage scenario in the experience becomes incredibly important. And what you discover, this is a quote from Bill Buxton again, is everything is best for something and worst for something else, and everything is natural for something and incredibly unnatural for something else. And so the dilemma of the user experience is balancing these things together to produce an application that is intuitive, approachable, and discoverable. And this is part of the art of building systems. I did a session earlier on this morning when I talked about architecture being part art, part science, and part art, and a third part is the balance between the two. That's nowhere more true when you build user interfaces. Some of it is science, an awful lot of it is art, and frankly, the balance between them is incredibly important. And so, when you think about building user experiences, invention is one thing. Creating something new is incredibly hard, and I'll show you some examples of that in a minute. Innovation and continuing innovation is a place where many companies spend many time, as do we. I wanted to show you a quick video. This is some work that's been done at the University of British Columbia. It's a couple of students who've produced a device here called PQB that is a two-dimensional device. It's made up of 5 LCD screens, but have a look at the three-dimensionality of these pictures. Can we run the video, please?
PQB, a personal cubic display that arranges 5 flat panel screens into the shape of a box. By tracking both the user and PQB, we can render perspective-correct images and support tangible interactions, such as rolling and bouncing objects, navigating a large scene by tilting, and poking and prodding objects.
It's amazing stuff. So a couple of graduate students working on this, where it's amazing how we've taken what are two-dimensional displays and created what appears to be incredibly three-dimensional. Think about the user experiences that you can start to create with some simple technology like this that I think, frankly, is going to have huge, huge impact. So the integrated experiences are incredibly important. Here's a place where I want to talk about innovation. There was a very simple thing that was done on the Windows Phone that wasn't done anywhere else. And this is what it was. Most applications that were built on a phone, you had a display that was about that big, and you could cram as much data as you could into a little screen. And one of the innovations on the user experience on the Windows Phone, why are you limited to one screen? Why can't I take that screen and pan it across a space, a UI space? Seems pretty simple, but it's like any good innovation. Nobody else thought about it until you saw it here, and here it seems terribly obvious. And so the ability to innovate in the user experience on the phone and create applications that have a very wide user surface where you pan back and forth is really going to change two things: the way mobile applications are going to be built, but also the way you can build an application that runs on a smaller device and have it run on a larger device without any change, which is going to be an incredibly important thing that we believe. So then the final aspect of user experiences is getting inside of somebody's head. It sounds kind of hard, but what you're really trying to understand is the intent of the user and then connect all those intents together so that you can be predictive of what the user is going to try and do. Trying to understand the psychology of your user as you build this user experience is incredibly complicated, but allows you to reach out in a different way and really think about applications and how they're being built and the user experience in completely different ways. Let me give you an example. If you think about all the ways that you can communicate today, video, voice, email, multitudes of ways that you communicate, each one of those tools that you have today has its own list of contacts, its own storage scheme, its own authorization scheme, its own authentication scheme. Each one of them has their own private systems. And in order to be able to get this common view, you need to have a unified view of those various elements. We believe this needs to be done, we implement this in the Link product, but in fact, having a common user context is incredibly important to the cloud and to user experience. There are simple ways of doing this, but we believe that this, together with identity, which this is a big part of, with authorization again, is going to become a massive discontinuity in the way applications are put together and the way you can start to build applications in this common context. So if we go to the cloud, we think that that context is going to be stored in the cloud. Over time, your context will be stored on the cloud and they're shared with all your devices and synchronized across your devices. But when we look at the cloud and you look at this curve, which is an adaptation of the Gartner consumption curves, you start off at a trigger point in the cloud, get to what we call the peak of inflated expectation, followed shortly by the trough of disillusionment, the slope of enlightenment, and then hopefully you get to the plateau of productivity. A lot of people think about the cloud in this way today, and there are many cases it's being oversold, under-implemented. But however, we are seeing many, many successful deployments today of either software as a service, platform as a service, and frankly, even with infrastructure as a service in fairly broad ways. So what constitutes a cloud? Virtualization does not equal a cloud. Virtualization equals consolidation, but it doesn't equal a cloud. The biggest element that I believe makes something a cloud is the underlying automation of the underlying services, and I'll show you that in a minute, coupled with management tooling and the various performance abilities, scalability, etc. So let's go in and look at some work that we've done around what we call the I/O models. We've been able to look at infrastructure and catalog it by 4 types: basic, standardized, rationalized, and dynamic. And we can define the attributes of each one of those tiers. We can actually tell you what the best practices are, the technologies you need, the task profiles, the workflows, the runbooks, everything you need to be implemented. We've also done some very good business intelligence analysis against our installed base with many of our customers around the world. And what we find is that for Exchange, for a system that's implemented on a basic infrastructure, you can expect about 10 hours of downtime a year. And if you move up the stack to rationalize, you can get about an hour of downtime. So think of that, 10 hours to 1 hour. And in the case of SharePoint, you can take the cost of running a SharePoint server from about $23,000 to about $1,000 by just moving up the stack. However, when we go back and look at our installed base, about 2/3 of our installed base is still running in basic. Even though we can clearly identify the cost benefits, the time benefits, the real value of this migration, it's not happening. And so the way to think about the cloud from an infrastructure perspective is to think about moving to the cloud as leapfrogging to dynamic. You can either move most of your infrastructure, some of your infrastructure, or even a workload to the cloud, and take that workload and migrate that workload from a basic infrastructure with its attributes into a dynamic application and its attributes and all of the benefits of manageability, supportability, uptime, scalability, elasticity, resiliency, etc. And that for me is a way of thinking about the cloud, is the ability to leapfrog up that stack and do it quickly by migrating your workloads into the cloud in interesting ways. Let's take a quick look at 2 orthogonal dimensions. Here's a quick stack going from networking and hardware all the way up through the application. Here's another stack of some attributes of cloudiness. These are various automation layers, if you want to think about it that way. There's nothing magical to this list. I actually made the list up so it was the same size as the other one. No other reason in terms of this stack. But it's a pretty good example of attributes like elasticity, resiliency, quota management, deployment, placement, iteration, versioning, and so on. What happens is that in any underlying infrastructure, if you plot that on 2 dimensions, your infrastructure today is running at some intersection point, probably towards the lower left-hand corner, and there's incredible benefit of moving into that upper right-hand corner by automating some of the underlying attributes. Automation is about repeatability and predictability. It's about taking something and making it fairly simple and repeatable. Let's look at something like elasticity. Let's say you have an application today that runs on 10 servers and you want to add 10 more. You want it to be elastic. Hopefully your application has been written to be elastic. Let's assume it has. But you've now got to go knocking on the door of some hardware guy saying, please, 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 can I have 10 more servers? And yes, having them, if you can get it to me within a month, that would be great. I can take that scenario and automate that in the underlying infrastructure and actually have that today inside of Windows Azure being provisioned in real time in less than a minute. That level of automation of elasticity is what the cloud brings. That benefit of elasticity is what the cloud brings. And I can actually have that same discussion around elasticity and resiliency, but I can also make the elasticity be automated in the sense of when I see my load reaching a particular level, automate a workflow that actually adds some more servers. Or I might know that my application tends to get a peak load at 7 in the evening. Add some more servers at 6 and take them down at 8. All of those automations of elasticity are what comes with automation and with workflows around automation, which to me are some of the key attributes. However, private clouds need a workload. I said this earlier in the earlier session, I'll repeat it here again today. Private clouds on their own do nothing. Private clouds on their own allow you to log in and hopefully print. But a private cloud without an application, without a workload, doesn't mean anything. You have to plan your private clouds using the scenarios from your applications. And this is causing a lot of tension in many companies because it's the infrastructure dudes who are trying to build the private cloud and the app dudes who are trying to use it, and they're not really talking to one another. And really what's required is these two organizations need to communicate more about the infrastructure and what you're trying to deploy inside of that infrastructure. Let's look at some of these scenarios again. Here's the stack that I talked about again, going from the lowest level all the way up. If I look at virtualization, where I said virtualization does not equal cloud, this is the scenario. If you actually look on that side, on your right, in the case of Windows Azure, all of those underlying elements, the self-service portal, all of those automation elements are implemented in the platform infrastructure. If you're just running virtualized today on some available virtualization server, where let's assume it's a public server that's virtualized as an infrastructure as a service, you then have to decide which operating system do you want to deploy, which database do you want to deploy. You have to make all of those decisions and all of that automation, which starts to get to the core value of platform as a service as opposed to infrastructure as a service. If you look at it on the application side, again, what I'm interested in here is what I've called the unit of deployment. That equals what are you responsible for when you make those decisions. So I talked about you have to pick the operating system, you have to pick the database, the operating system. Let's say you're running on Amazon. Do you want Windows? Do you want Linux? Database, do you want SQL Server, MySQL, NoSQL? Which database do you want? Do you want PHP or ASP.NET? Which framework do you want? Which tool do you want? And then write your application. And so in the case of running on top of something like EC2, you actually own all the decisions about the infrastructure that you want to run on. But not only that, you're responsible for running them. In other words, if your database fails, hope you've got a backup somewhere because you need to be able to go find that backup and restore it. You are responsible for the running, all the running elements that sit in that environment, as opposed to Windows Azure, which will take responsibility and accountability for all of those pieces. Here's a great example of Windows Azure. This is actually in Mexico. The Mexican government, their tax department deals with goods and services tax, or VAT, and they have a system today that's little pieces of paper, 2 billion little pieces of paper a year. And they decided that they needed to automate that. Primary reason was to collect more of the money than they were collecting. And so they looked at two options. One was to build out a brand new system, which would have meant implementing it in 2 distributed data centers in order to give them geo-recovery and disaster recovery. They figured that cost would be about $100 million, either building on existing facilities or new facilities. Or they could build it in the cloud. And they built it in the cloud, built it on Windows Azure. It cost about $3 million to build the application in Azure, and cost about $25,000 a month. So they were faced with this interesting choice. $100 million to build a data center, or $5 million to have the application running on Azure for 3 years. Easy decision for them. But the interesting part of the decision, frankly, was where this application runs. We don't have a data center in Mexico. In fact, we have a data center that's in San Antonio, Texas. So the Mexican government runs their tax system in a data center that runs in Texas. So a lot of the questions about data sovereignty actually have a price. And in this case, the Mexican government decided that for $95 million, they'll put their data in Texas because they felt comfortable and reliable with their data there and their ability to interact with it and our ability as a provider to deal with the individual parts of that data. So let's sort of do a little bit into different kinds of Azure applications. Symmetrical applications in the cloud. Best example of that is mail. Whether you're running mail on-premise or mail in the cloud, same mailbox, no matter where you go. Exactly the same mailbox, one way or the other, completely symmetrical. The one that I find very interesting is asymmetrical, which is taking existing applications and bursting it out to the cloud, or doing something different in the cloud than you might have done on-premise. In fact, any well-written ASP.NET application today is a candidate for this. Either a candidate for scalability in the cloud when you need it, or for extension of the functionality in the cloud. I'll give you an example of asymmetricity. We have an application that does medical imaging storage, the Imalga product. So we take these large medical images, which are huge files, and we chunk them up, encrypt them locally, and store them in the cloud. The only way to access them is to pull the encrypted image down locally, decrypt it, and reassemble it. Why would you do that? We've done it with a couple of hospitals in the US, and they save $20 million a year on storage. Plus, they feel very comfortable that those medical images sitting in the cloud are completely encrypted and private there. And so there are many ways that you can go through this asymmetry and actually get value of the cloud by taking existing applications and extending them, not only with functionality, but frankly with storage. So finally, let me talk a little bit about the people side of it. When you think about building out a private cloud and all of the underlying technologies that are in a private cloud, whether it's networking and IPv6, it's management and automation and consoles and scripting, infrastructure, virtualization, servers, identity and access, those are all the underlying technologies and elements that make up a private cloud. The challenge, the real question for me, is who is accountable for that private cloud? Where does the governance sit for that private cloud? And so what I think is going to happen, my opinion, is that many of the folks working on infrastructure need to recast some of what they're doing to think about this private cloud deployment and how all these individual technologies are being aggregated together into this broader view of the private cloud. There is no one person who's going to be an expert in each one of these technologies, and it's very important that we assemble teams of people based around what we call capabilities and the assembly of these capabilities into the delivery of frameworks and infrastructures. Here's another area. When you write an application that's running in the cloud, running on platform as a service, we'll pick on Windows Azure. Who owns that running application? We own the infrastructure. We own the Azure infrastructure. We'll make sure that the infrastructure is reliable, elastic, manageable, upgradable, secure. But when you write an application in the cloud, you own it. We don't own it. It's your application. If it's written well, great. If it's written badly, we're going to just have a bad elastic application. And so another part that comes out of the cloud is actually around instrumentation and diagnostics and telemetry of the applications that you're writing. And so I think we're going to see a real growth in some of the management opportunity about how do you manage, maintain, operate, keep healthy running cloud applications. So I think that there's actually a huge growth opportunity here in terms of skill set of some of the things that happen in the cloud. Let's just look what happens if you're a DBA. Today, if you're a DBA working on a database, let's say back. Let's say 10 years ago working on a database. One of the most important things that you could do is lay out the tables to a disk drive. You actually put a table on a disk drive because you wanted to make sure that when you ran a join, that the two tables were sitting on disk drives so that the heads could spin independently. Then you would actually take the schema, denormalize the schema, create the query, make sure you've got the indexes written correctly, and so on. Well, today, you wouldn't actually do that table to disk drive layout because there's nothing to be gained from that, and so the abstraction went from disk drive into data space. When you go to the cloud, the same thing happens. There is no concept in the cloud of a disk drive when you run with SQL Azure. There's a concept of a storage space. We'll manage the optimization, we'll manage the query for you. So you have the degrees of freedom that you have there are different, but you still need to take the schema, denormalize it, write good queries, and index it appropriately. Otherwise, again, you just get a bad elastic database. So the attributes of the cloud, you can abuse them or take advantage of them, but the skill sets that you've got today as a DBA are just as important in the cloud, or even more so. Here's another example. Let's say you've written an application in the cloud, this wonderful, secure cloud, but for some reason, you've decided that threat modeling and secure development life cycles are not important. I'm not sure why you would do that, but let's imagine that. In that scenario, the hardest problem you can get is an elastic virus, because if you haven't tackled threat models, if you haven't tackled security and reliability, you actually are just as vulnerable in the cloud as you would be any other way. Let me finish on this then. We've got a video over here that talks about integrating in the cloud, and it talks about integrating Bing, Tell Me as a voice service, and Xbox. And you'll be able to see this released on Xbox very soon, the next couple of months, on the Xbox 2, this deep integration between the products. So can we play this video, please?
It's time to come together for entertainment the way you want it, all with your voice.
Xbox, home.
All your entertainment in one place.
Xbox, video.
Searchable, simple. When you say it,
Xbox Bing, Harry Potter.
Xbox finds it.
Xbox, play Harry Potter and the Deathly Hallows Part 1.
Never miss a moment of what you enjoy.
Xbox, go home.
Hey, your favorite show's on.
We're getting technology out of your way so you can enjoy the show.
Xbox, watch live TV.
Nothing should come between you and the entertainment you love. Movie night is more amazing. Game night is more amazing.
Xbox, pause.
TV is more amazing when you are the controller.
Xbox, play.
So you'll be seeing this on your Xbox in the next couple of weeks in the next primary download. What I think is amazingly important about this is the blur between the end user device and the cloud, accessing Tell Me for voice, Bing for search, and various services for content delivery. And that is what's going to make, I think, is what's going to make the cloud different. I think that the road ahead is going to be this fantastic opportunity. We're not at the end, we're actually barely at the beginning of the cloud. And this road ahead of taking incredible applications, building fantastic user experiences that I think are going to be vastly different to those experiences that you've built before, and integrating them into the cloud really has this phenomenal opportunity that we think we present to you, whether you're on the infrastructure side or the developer side. And when we actually step back and think about the billions of users of our technology today, from consumers into the enterprise side, I think that the opportunity for all of us is incredible about how we can change the world now. We can make the difference in the way people use technology, consume technology, and frankly, make their lives a whole lot better. Thank you.
So I think it's a great opportunity just to get a feel for what Microsoft's bringing out and what the technology is going to do.
What I love about TechHead is it really brings together the community of .NET developers and Microsoft platform guys, and they're really trying to push the envelope.
The expo's been fantastic. The booths, the giveaways, obviously all the technology there that all the vendors offer.
Yeah, it's the pinnacle of techie geekdom.
I love Windows Phone.
I'm really excited about the stuff in HTML5, CSS3 and all the media queries that you can use because it's going to be fantastic for responsive web design.
Really enjoyed the light switch, the new product that they've launched.
Oh look, it's the community opportunities, the chance to get together and talk with other geeks and hear what they're doing and see what they're doing. There's been some great sessions.
Went to a real-world Power Pivot one last night with Graham Paisley that was just excellent with real-world examples and how to actually use it in real world. It's very good.
I just passed just now the Microsoft 7680 exam.
Yeah, I really enjoyed the hands-on labs just because they've given me such a valuable insight.
Vision for the future of storage. Yeah, no, it's been excellent.
The one demo that I really enjoyed was the Kinects with the fruit slashing fruits.
It's been great fun, my first time. I'll definitely come back next year.
Take it, love it.